轻人所用的煤炭是由天然气资源。
这是我所知在国内第一个比较细致的节能减排实验室。
Vanadium titanium ore hydrogen shaft furnace direct reduction smelting technology. Vanadium and titanium are important strategic resources. Vanadium, known as industrial monosodium glutamate, adding a small amount of vanadium in steel can significantly change the performance of the steel. Meanwhile, vanadium is also the important industrial catalyst and the material of large-scale energy storage battery in the future. Titanium, with the advantages of lightweight, high strength, and corrosion resistance, is an important raw material of aviation, spaceflight, and national defense. It is also the most dispensable material for the development of modern high-end manufacturing. Vanadium titanium magnetite is a kind of complex ore giving priority to iron, titanium, vanadium, and associated with a variety of elements. The contained vanadium and titanium resources account for 98% and 65% of the world vanadium and titanium resources reserves respectively. At present, the smelting process of vanadium titanium magnetite at home and abroad is mainly the traditional blast furnace, converter, and rotary kiln, electric furnace process, which has the disadvantages of small production scale, high energy consumption, severe pollution, high VTI production cost, low recovery rate, and etc. How to extract the vanadium and titanium resources from the vanadium and titanium iron ore in the manner of high efficiency, low pollution, low cost, and high yield has always been a worldwide problem. Beijing Shenwu Group has developed the new vanadium titanium ore hydrogen shaft furnace direct reduction clean smelting technology. By introducing the PERED hydrogen shaft furnace patented technology from Germany, MME, and combining with Shenwu's regenerative combustion technology, which can realize the high effective and comprehensive recovery and utilization of the valuable elements such as iron, vanadium, and titanium. The complete process has reached the international leading level. 1. Taking common hydrogen from coal, pyrolysis gas, and natural gas as raw material without the high energy consumption and high pollution working procedures such as coking, sintering, and blast furnace, especially suitable for the energy structure characteristics of rich coal, less gas, and oil starvation in China. 2. By adopting the process of hydrogen shaft furnace direct reduction, melting separation furnace TI extraction, converter, V extraction, the recovery rates of iron, vanadium, titanium have reached above 90%, 75%, and 95% respectively, which are higher than that of traditional blast furnace process by 1%, 5%, and 95% respectively, thus truly realizing the high effective comprehensive utilization of iron, vanadium, and titanium resources. 3. Taking 100% vanadium titanium ore as raw material, the vanadium slag grade and titanium slag grade can reach 12 to 22% and 45 to 60% respectively, which can be used as the high-quality raw materials for the follow-up deep processing of vanadium and titanium. The produced semi-steel is the high-quality iron material for producing high-quality steel, special steel, senior castings, and forgings. It is conducive to the development of high-end equipment manufacturing industry of aviation, aerospace, rail transportation, and marine engineering of China. 4. The smelting temperature is about 600 degrees centigrade lower than the blast furnace. The refining energy consumption is lower than that of blast furnace iron making by more than 20%. Carbon dioxide emission reduction is above 20%, even can realize zero emission of carbon dioxide. The pollutant emissions of SOx, NOx, and PM2.5 are reduced by more than 90%. 5. The capacity of single-unit equipment is large, which can process vanadium titanium ore for more than 2 million tons per year. so as to meet the requirement of large-scale processing vanadium titanium mineral resources. Vanadium titanium ore coming from the yard will be made into vanadium titanium mineral powder by the working procedures of crushing, screening, fine grinding, and etc. Sending vanadium titanium mineral powder and binding to damp mill after mixing, grinding, and refining, and then sending to the disc pelletizer to make pellets. The qualified green pellet will be dried and preheated by chain grate, and then be sent into the rotary kiln to make into vanadium titanium oxide pellets by high temperature roasting. The raw coal coming from coal yard will be sent into the fluidized bed gasifier after crushing, screening, and drying. The gasification agent from air separation device and steam boiler will enter into the gasifier from the lower part of fluidized bed gasifier to make uniform fluidization of pulverized coal in the gasifier. The gasification agent and pulverized coal will make gasification reaction in the gasifier. The produced coal gas will move upward and enter into the cyclone dust collector via gas piping. After secondary dust removal, though, waste heat recovery and ceramic filter, the crude coal gas can be achieved from the coal gas after dust removal. After the working procedures of washing and transformation, the crude coal gas will be made into the qualified reducing gas, and then enter into the desulfurization and decarburization system after mixing with the top gas of shaft furnace. The purified reducing gas will be preheated by heat exchanger and heated to about 900 degrees centigrade by regenerative reheating furnace, and then enter into the hydrogen shaft furnace. The vanadium titanium oxide pellets will be sent to the feeding system at the top of shaft furnace by overhead hoister. The shaft furnace is composed of preheating zone, reducing zone, central carburization zone, and lower cooling area. The hot charging melting separation furnace can remove the lower cooling zone. The vanadium titanium oxide pellets coming into the shaft furnace move downward. The reducing gas, about 900 degrees centigrade, moves upward from the bottom of reducing zone, so as to realize the heating and reducing of vanadium titanium oxide pellets. The gas after reaction will be derived from the furnace top. The top gas will go through the heat exchanger to recover the waste heat and remove the dust. After this, part of them will be sent to the regenerative reheating furnace as the heating fuel. Another part will be mixed with new reducing gas for circulating utilization after decarburization and dehydration. The reduced pellets will continue to move downward and come into the carburizing zone. In the carburizing zone, the pellets will contact with the cold reducing gas coming from the lower part and be cooled. Meanwhile, have carburization reaction. The carburizing zone and cooling area are provided with burden feeder, which can prevent the burden bond. The shaft furnace products can be divided into HBI, hot briquetted iron, HDRI, hot direct reduced iron, and CDRI, cold direct reduced iron, which can meet different follow-up processing requirements. The vanadium titanium ore metallized pellet produced by shaft furnace, the reducing agent, and auxiliary materials will be sent to the top feed bin and then be sent into the melting separation furnace by feeding duct. The electrode and furnace burden will generate arc heating, and the heat will be transmitted to the furnace chamber. The reduced pellet will be heated and melted by arc heat and resistance heat so as to achieve the titanium slag and vanadium bearing hot metal. When the titanium slag and vanadium bearing hot metal generated from melting and separation inside the furnace reach a certain height, using opener mutt gun or oxygen to open the slag hole and tap hole respectively to send out the Ti bearing slag and vanadium bearing hot metal to the slag ladle and hot metal ladle. The vanadium bearing hot metal will be sent to the vanadium extraction workshop by hot metal ladle car, and then be blued to vanadium slag and semi-steel by oxygen. After the blowing completion, firstly discharge the semi-steel into the hot metal ladle, and then discharge the vanadium slag into the vanadium slag ladle. The sewage generated during the production will be sent to the sewage treatment unit for centralized processing and circulating utilization. by adopting the process of hydrogen shaft furnace direct reduction, melting separation furnace TI extraction, converter V extraction developed by Shenwu. The produced titanium slag is the raw material for producing titanium dioxide and titanium sponge. The produced semi-steel is the high-quality raw material for smelting clean steel, special steel, senior castings and forgings, and the produced vanadium slag is the high-quality raw material for producing flake-like V2O5, vanadium iron, vanadium nitrogen alloy, and vanadium redox battery. Thus, to truly realize the high-efficient utilization of iron, vanadium, and titanium resources, and thoroughly solve the worldwide problem of great smelting difficulty and low recovery efficiency of vanadium, titanium, iron ore resources. Shenwu's VTI or hydrogen shaft furnace direct reduction clean production process overturns the traditional blast furnace iron-making technology. With high pollution and high emissions, it is the best choice for China's steel industry transformation and upgrading, improving product quality, reducing air pollutants and carbon dioxide emissions, as well as realizing the comprehensive utilization of iron, vanadium, and titanium resources.